Hey guys, go ahead and get out your note sheet for systems of equations word problems. So there's three basic styles to set up word problems that you're going to see mainly for systems of equations. So if we can focus on each of these three, then you should have no problem with setting up word problems as you see them. We'll start with the easier one. The first one is something you've actually already done earlier this year, and it's when you're going to have two equal sides, or they're going to give you two situations and ask you to find when they're the same. And we did this when we had a variable on both sides, and you probably just didn't realize it could be a system, but we'll take a look at how that's a system of equations, and then you solve it the same way we did earlier this year. You write the equation and then set them equal to each other. Second style is using substitution. And this is going to be when you have information given to represent one of your variables. You'll write that equation first, and then you'll write your second equation based on the rest of the information. So basically, they're going to tell you that something is equal to something else, which is set up to be a substitution style word problem. And then the third one's your most common, and this is when you have two totals. And this one I see probably 95 to probably almost 100% of the time, to be honest. And you're basically going to be given two totals in the word problem somehow, and basically you're going to write an equation based off of each total. So if one of the totals is the amount of money Joe spends, that's his equation. Then the other one's the amount of money that Lisa spends, then that's the second equation, and then you would solve from there. So these are your actual steps for solving word problems. Step one is to definitely identify or indicate what each variable stands for. It's very important you do this because at the end of a problem, it's not necessarily ordered pair. You're stating what each of those variables represented. So you want to begin the problem by identifying what your variables are. What is x, what is y? Step two, write your system of equations to solve the problem, and this is going to depend on the kind of word problem it is that we just talked about. Step three, solve using any method you want. Step four, check into both of the original equations, and then step five would be to state your final answer with your labels. Since it is a word problem, we want it to make sense. This is just a nice little visual to see those steps again that you kind of work your way through. Always define variables first, and then you work your way into writing the systems of equations, solving, and then checking and stating your solutions. Alright, so we'll start with the easiest word problem first, and we actually need to make an adjustment. That's supposed to be, and I apologize, a 200 startup fee, not 205. So if you can fix that, it will make life a lot easier for us in a second. So this one's two equal sides example, and this is similar to what we've done earlier this year. In the future, it's not going to tell you what kind of problem it is. You're going to have to understand how to set it up, but for now, this should help. So this says Get Fit charges $200 startup fee and is $10 per month. VA Fitness is a $20 startup fee and is $25 per month. After how many months will it cost the same to use each gym, and then what is that price? So we do have two different equations here, one for each gym, and we want to start with at least identifying what our variables are. So the two questions are asking us for after how many months, so I'll let X be months, and then Y would be that total price. So what we want to do is we want to write an equation for Get Fit. So Get Fit said it was $200 plus $10 per month, and that would equal the total price that it costs to have Get Fit gym, or be a member of Get Fit. And then VA Fitness is $20 plus $25 per month, and that would equal the total for their gym. So if you really look at this, this is technically substitution because y equals both of these. Y is 200 plus 10x and y is 20 plus 25x. So when we go to solve it, we're technically going to use substitution and basically replace y with what it equals, which is the two different parts of this equation. So you can go ahead and stop and solve this and check and see what we get for x, and then we'll solve for y and finish answering. Okay, so when you solve for x, you should end up with x equals 12, and then you can plug that into either of the original equations, and we end up with y equals 320. So our final answer here, and I know a solution to a systems is where they would cross each other as an ordered pair, but what's going to make more sense as a word problem is not necessarily writing the ordered pair, but writing the labels that go along with each of your variables. So x was months, so 12 months, and then y is $320 since y was your total price. Okay, next we're going to jump into looking at some substitution examples. So number 2 says two numbers add up to negative 56. one of the numbers is 4 more than twice the other number, what are the two numbers? So again, we're going to at least start with identifying our variable, so x and y. And this one, we don't have specific labels, we just have two random numbers that we don't know. So we'll call x the, I don't know, the first number, and then y could be the second number. Since they're two different numbers, they have two variables for them. So with substitution, you basically take the sentences, get rid of the words, and write equations. So two numbers add up to negative 56. Well, that's pretty easy. We've got these two numbers that are variables, x and y. So x plus y added up equal negative 56. And then the second equation says one of the numbers is 4 more than twice the other number. So it doesn't matter which one we pick because we don't have specifics here. So one of the numbers, I'm just going to call that x. And then the word is my equal sign. So is 4 more than would be 4 plus twice the other number, and the other number would be y if we're using x. So we've got x equals 4 plus 2y. So for this setup, we've got our systems. You can solve it any way you want, but this one's ultimately kind of set up for you to use substitutions. So I'm going to go ahead and actually use substitution. So I know x can be replaced with 4 plus 2y. So in that top equation, I'm going to replace that. So 4 plus 2y, where x was, plus the y that was already in my top equation, should equal negative 56. And then I can combine like terms. So then I'll have 4 plus 3y equals negative 56. Subtract your 4, and then divide by 3. And then we end up with y equals negative 20. So once we know y, we can plug it in and solve for x. So I'm going to just go back into that bottom equation there, and I know that x is 4 plus 2y, and if y is negative 20, then I've got 4 plus 2 times negative 20, which is going to give me 4 minus 40, and x should be negative 36. So this kind of word problem is not necessarily referring to any kind of specific labels, so you could write this one as an ordered pair. You can also refer to negative 36 as your first number and negative 20 as your second number. And if you do your checks and you add those, they're going to give you negative 56. And then if you check the negative 36, it is that y value doubled, which would be negative 40, and then 4 more than negative 40 is negative 36. So we know that the check does work out, and our final answer is good to go. All right, in example 3, and again, substitution for this one, you have $4.45 in dimes and quarters. The amount of quarters you have is 1 more than twice the number of dimes. How many of each coin do you have? So we'll start with our variables, and here I'm going to use dimes. I'm going to use D and Q, so it makes it a little bit easier throughout the problem instead of X and Y. So D will be the number of dimes we have. Q will obviously be the number of quarters. And then I'm going to figure out what my equation should look like. So I've got this total of $4.45, and that comes from adding my dimes and my quarters. When we go to write this one, though, because dimes and quarters have a value and that total is a value, we need to include the value of each dime and the value of each quarter. So I don't want to just say that dimes plus quarters equals $4.45. It's the value of each dime, and I know dimes are worth 10 cents, and as a decimal that's 0.10. Quarters are 25 cents, so that's going to be 0.25. And I only do that because this entire equation is dealing with value. So total value, and then you want value per coin. Second sentence says the amount of quarters you have is, and here's that equal sign, so Q equals 1 more than, so 1 plus twice the number of dimes would be 2D. I don't have to include the values here because I'm not talking about a total value. I'm just dealing with coins, so no 0.10 and no 0.25 for this. Again, this one's really set up as a substitution where we're going to change Q, and so I'm going to go ahead and work that out, and you guys can press play and try it on your own and press play when you're ready to check. Alright, so when we go ahead and solve and using your substitution, you should end up getting that dimes equals 7, and then when you substitute that back in to your equation for quarters and do 1 plus 2 times the number of dimes, we end up with 15. So our solution looks like 7 dimes and 15 quarters, and if we do our check, 7 dimes would be 70 cents, and then 15 quarters would be $3.75, and $3.75 plus 70 is where we get our $4.45 from. So anytime you have a problem that deals with value of coins, you want to include the value if you're dealing with a total that is a value. All right, so the last kind we're going to look at is definitely the most popular, and it's when you have two totals. So we'll take a look at this one. It says you're selling tickets for a high school basketball game. Student tickets are $3 and general admission are $5. You sell 350 tickets and collect $14.50. How many of each type of ticket did you sell? So again, our X and our Y are the different kinds of tickets. So we're referring to student and general admission. So I'm just going to make X be student, and I'm going to make Y be general admission. And what's going to help with these kind is identifying your two totals so that you understand that each equation will just be set for that kind of total. So I see a total of 350 tickets and then a total amount of money as $14.50. So if I can at least begin by setting one equation equal to 350 and the other one equal to $14.50, that's a good start for these kind of problems. So the 350 deals with tickets, and when I'm talking about tickets, I'm just referring in general the number of tickets. So I have student and general admission. I don't know how many of each I sold, so I'm just going to keep that as X plus Y, so the total tickets, X plus Y, equals 350. The second equation with the total of $14.50 is a value. So if I'm using X and Y again, I have to include the value in this equation since $14.50 is a money value. So student tickets are $3 each. So every student ticket was $3. So that's going to be 3 times the number of student tickets. Every general admission was 5. So that's 5 times the number of general admission, and that total was $14.50. So from here, you can choose which method you would want to use to solve. You could use substitution. I prefer, personally, elimination, so I would probably use multiplication elimination. That's the way I'm going to show it, but you can pause the video and solve it any way you want. We should all get the same answer, and then you can press play to check and see what you get. Okay, so for elimination, I multiplied my top equation by -3 to get rid of the x's, and ended up with y equals 200, and then plug that in and solve for x, and x should be 150. You might have done yours a little differently, but your solution should still be the same, which means we would have sold 150 student tickets and 200 general. If you go to do your check and you do 3 times 150, that's going to be 450, and then whenever you do 5 times 200, that's going to give you 1,000, and then 1,000 plus 450 is going to give you your 1,450. And then again, when we add x and y, that's definitely going to give us 350, so we know these are the right numbers for this one. All right, example 5 says last Saturday Shakira bought pants and shirts for her new video. Each shirt cost $125 and each pair of pants was $225. That's way expensive, but I guess she can afford it. She came home with 26 items and spent exactly $4,950. How many pants and shirts did she buy? So our question is definitely asking us for pants and shirts, so we're going to go ahead and make our variables be pants and shirts. And if you ever want to use like P for pants and S for shirts, that's fine. I usually default to X and Y unless it's money. Next, we're going to go ahead and look for our totals in the problem. So it says she came home with 26 items. So one of our equations will equal 26, and that's going to deal with just items. And items here would be your pants and shirts. So we're just going to say X plus Y. The number of pants, number of shirts was 26. Second equation was her value, so she spent $4,950. So instead of just plain X and Y, we have to include how much each pair of pants and how much each shirt is. So according to the problem, pants, which I have as X, were $225. So it's going to be $225X plus Y, and that's going to be your shirts, and they were $125 each. So again, you can use substitution if you like substitution. I prefer elimination, so I'm going to show it that way. But this would be an easy substitution one as well, so you can pause, try it, and then press play when you want to check. So I multiplied my top by -125 to eliminate the smaller of the two variables, which was y, and I ended up with x equals 17, and then solved for y, and y was 9. So looks like we would have 17 pairs of pants and 9 shirts in order to equal that total. And if you add 17 and 9, you definitely get 26. And then when you include and try in the second equation the value of each of those, you will end up with $49.50. If you want to try this one completely on your own, just pause the video and then you can press play whenever you want to check it. But I'm going to continue with our first few steps for this one. So we're talking about a dance and you're purchasing bags of balloons and hanging stars for $19.20, and then you realize that you didn't have enough, so you had to go back to the store again and buy more balloons and hanging stars for a different value, and then we want the price of each item. So again, our variables are going to be each item, which was balloons and then hanging stars. This one's a teeny bit different because our two totals are both the amounts of money that you spent, but it was each trip. So the first trip you took, you spent $19.20, so we know we can at least start with $19.20. Second time you went, you spent $15.80, so I know this is going to be my two equations. So since $19.20 represents your first trip to the store, you want to include what you purchased that time, and that was 6 bags of balloons, which would be 6x, plus 5 bags of the stars, so that's going to be 5y. The second time you went back to the store, you had to buy 8 bags of balloons, so 8x, plus 2 bags of the stars, plus 2y, and that was $15.80. So this one's not as nice, it's not as easy as the other ones have looked, so you really can't use substitution unless you kind of completely isolate one of these variables, which would be a little bit more work. So the best bet here would definitely be to be using elimination and either creating the same number for the x's or the y's, and so we're going to have to change both of these equations. And I'm looking at 6 and 8, and I know the smallest they go into is 24, and 5 and 2, the smallest they go into is 10, and I'd rather make 10 than 24. So I'm going to go ahead and multiply my top all by 2, which is going to give me a positive 10, and then I want that bottom equation to be a negative 10, so if it's 2 times something to give me negative 10, that's going to be a negative 5. Alright, so whenever I multiply the entire top and bottom, I should end up with this 12x plus 10y equals 3840, and then negative 40x minus 10y is negative 79. So from there, you're going to be able to eliminate your y's and continue solving for x. So when we get x, we should end up with a positive, which is good because we don't want the value to be negative. And we end up with $1.45 for x, which tells us that it looks like the balloons were $1.45 each. And then next we're going to go ahead and solve for y, which is the value of the stars. And you're going to have to plug x into one of those original equations so that you have that value of y, and we can finish the problem. I think it looks easier to plug it into the bottom since it's smaller numbers, so that's what I'm going to do. So when we substitute x back into either of those equations, we should end up with y equals $2.10. So final solution, and what you would want to do is definitely check that in both of these to make sure that those totals match and that we know for sure those are your prices. So that is it for the systems word problems. We will definitely practice a little bit more of these throughout class, but you will see more of these than plain system problems when you take your SOL and other major assessments. So hopefully these weren't too hard to pick up on, and I will see you all soon.